All right, so let's get started. Um, I'd like to thank you that you are here that early in the morning, especially because yesterday was the party, so I'm really glad that you are here. So I'd like to give you next around 50 minutes a short introduction to the Kotlin programming language. So I've called this talk the Chronicles of Lost Semicolons. So because in Kotlin you do not have to use semicolons anymore to end your statements. So now the semicolons have to go somewhere. So where did they go? They go to colonscope. Colonscope is like a language where you mainly use the semicolons, so they found a new home there. So who am I? My name is Christian Woerz. I'm a senior full-stack engineer, trainer, and speaker. And you can just scan if you'd like this QR code or visit my website, type.rocks, and there you will find a GitHub link to all the code we'll talk about today. So what really is Kotlin? Well, Kotlin is heavily influenced from other languages like C# or from Java. And Kotlin is a multi-paradigm language developed by JetBrains, so by the people who brought us IntelliJ or Rider or WebStorm. So they have, it's heavily influenced by them, so it's also a multi-target language, so you can compile it to JVM, you can compile it to JavaScript, also to native, so for Linux, Windows, and macOS. And you can even compile it to, for example, use it with Swift or with C libraries. So but it's also open source, so you can also go to GitHub and then check for example, the GitHub stars and then work with the team behind JetBrains. So, but why should you consider using Kotlin? So Kotlin has great interoperability with many other languages. So for example, especially for Java, you can call Kotlin code from Java and can call Java code from Kotlin. But you can also, of course, call Kotlin code from Swift, or you can call it from C. And of course, if you use Spring Boot, if you are a Java developer, just quick show of hands, how many of you are Java developers here? Nice, some of you, perfect. And I think the rest of you C# developers? Okay, yeah, nice. So I think many of the C# developers will see some features in Kotlin which they already know, but the Java developers sadly don't know. So I think Java developers can also really take something with them. So as already mentioned, you can use it, for example, with Apache projects. You can use it in your normal Java project. So also if you have like your Maven project ready, you can just put Kotlin in there and then just use it. You can just use Kotlin in a small part of your Java project. So it's really cool to just get started by using a little bit of Kotlin in your existing projects. Also, if you are using Spring Boot as a Java developer, then it's one of the official languages which you can use to create Spring Boot applications. Even on the spring.io initializer website, you can then see that you can also just choose Kotlin to start with programming. So, but who does Kotlin really live? Who does it in production? Well, many great companies are using Kotlin. First, Android is using Kotlin as their main programming language for development. So if you are using an Android application, it's a high chance that you are using it with Kotlin under the hood. So because Google said you should mainly use Kotlin as a programming language, of course they are still also supporting Java, but they say whenever possible use Kotlin. Then also big players like Pinterest, Uber, Netflix, and Amazon also all use Kotlin in their productive code. And I'm from Switzerland, so I've worked in many insurance companies as a contractor, also in banks, and all of them are already using Kotlin in production in their backend applications, also in production. So for example, in an insurance company I've been working, they use it for their customer portal for all their microservices in their backend, and it's running since 2 or 3 years, so and they are still doing fine. I can still log in. So they should do fine. So now we are done with the presentation. Let's go right into the code. So we are here in IntelliJ, and this is what I've opened here is a so-called KTS file. There are two different types of file types in Kotlin. The .kt file, this is like the normal C# file or like a Java file. And then is the .kts file. The KTS stands for Kotlin script. That's not like something like Java and JavaScript. This only means that this is like compiled in memory. So I can do something like this. I can say I have my print line here. And as you can see now, it immediately compiles, but that it outputs it right beside. This is a feature of IntelliJ. So this is like a worksheet file, and I'm using this worksheet file because this way I can immediately output the value I've been showing you, so I don't have to like open a terminal or something like this. So, but everything I show you in this file, you can do in a normal Kotlin file, beside running code on top level. Kotlin supports top level functions, but not like code on this level. So I would have to like wrap it in a main function that I can to be able to execute it if I would use a KT file. But let's get started. So the first thing I'd like to show you is something really simple, like how can you instantiate a variable. So you would do it like this in Kotlin. You say, let's say NDC Oslo here, and as you can see now, we have the var keyword, then we have the name of the property, and then we have the type. So what we can do, because Kotlin knows type inference, we can remove this type here, and Kotlin still knows that this is a string, of course. If I now say I'd like to change this to name, as we can see, this of course works, but if I want to change this to a 1, this doesn't work, because even if I've removed the type, it's still strictly typed. So, but because Kotlin really wants us to write immutable code whenever possible, Kotlin also provides the val keyword. And now this is final, so I can no longer reassign the value. So, but now, how can I do, for example, things like string concatenation? I could do it like this. This is how we would do it in Java, but of course in C#, it's funny because I've taken a look into C# a little bit more by preparing this talk, and I've seen that many things we have in Kotlin are heavily influenced by C#, so you guys will feel at home. So we can do, instead of concatenating it, we can just use a $sign here, and then access our property right inside of our string. Now we can go even further, of course. We can say we want to access the length of the property, and then we have to use curly braces. So the next thing is, how can we do multi-line strings? So let's say we want to create a multi-line string. We can use quotation, uppercase, here these quotations, and then wrap our string in it. I have to now do a split view so that we can see the line breaks. As you can see now, nothing really changed, but I can now say I write a new line here, and we can now say it's Friday already. And if we now compile this, as you can see, we now have like this indentation here. To fix this, we can say trim indentation, and Kotlin then tries to figure out how we can indent this, but because we have here started not on a new line, it doesn't know how to do this. But if we change this here, now it has removed the indentation. You can also use, for example, trim margin and say, I want to create a prefix myself, then can use it like this to prefix your code and to make sure that you can use your own prefixes. So this is how you can use multi-line strings. Of course, in there you can also use your $sign and to access the variables. But let's go to another topic. So Kotlin, because it really wants us to use immutable code whenever possible, they also have changed many of the statements in Java, or which are statements in Java or in C# to expressions. So what we would do normally is, like, we have this string here. Let's initialize it empty, and we would say, if, for example, true, we say name NDC. Else we would say name equals nothing. Now, because of that, we would have to make our variable mutable. So to fix this, Kotlin said, well, we will make this if statement, not a statement, but also an expression. So what we can do here is, we can put this on the same line and remove this explicit assignment. And as you can see now, this compiles, and as we can see, if we check what the name contains, it contains NDC, because it takes the return of the if-else expression. And because of that, we can just remove this var and make it a val, because we no longer have to reassign the value. So now we have just a final variable here instead. The same thing we could do, for example, if we'd like to use try catch. We can say we have try catch here, and as you can see, this still compiles, and we don't have to like assign a value in our catch block, but can only use like the last element of our try or the last element of our catch block to assign it to our name. And if you would now say, for example, we have here throw exception, then in this case it would go into the catch block, and now in name there is nothing saved in it because the try block wasn't successful. Another thing you can do is, of course, pattern matching. So we don't know switch in Kotlin, but what we know instead is the when expression. So let's just create like a type and an object which can take any kind of type. This any is like in Java object, or also like you can save anything as you'd like. So we have this when expression here, and we say, well, with any, we can say, well, if this is a string, we just say, let's print is a string. And now, of course, because we are in this branch, Kotlin knows that this string, this any, is a string. So we can access the properties of this string and can say dot with the length, and is a string with length 0. And we couldn't do this, of course, if you were not in this branch, because in the other branches, this would just be of type any, and any doesn't have the property length on it. So we can go even further. We can say, well, let's say something is in a range. So we can say this is in a range from 1 to 10. Then we can say any is in range 1 to 10. And if I now change this, for example, to a 2, then we can see that it shows is in range 1 to 10. Now, we can, of course, not just print out something, but because it's not just a statement, it's also an expression, we can do the following. We can say we want to remove this, and we want to save this in a result here. And then we get an error because we don't have provided a default case, because if it's not a string or this range is not correct, then we have to provide something else. So we say else, and we say nothing found, for example. And now, as you can see, we get 2 is in range 1 to 10. If I change this, for example, to an 11, then I would get back nothing found. So this way we can use also this when expression to not only like assign something and do some return in there, but we can then just assign the value we get in these branches to our result variable. So, but now let's go to some functions. So we have the fun keyword. Let's say we have hello here, and we have our string, and we return a string here, and we say hello, and we have the name. Now, of course, we can just call this like this, NDC, and let's save it in the variable. And as you can see, of course, we can save this in a variable, and we can check what the value here is, and we can see hello NDC. Now, Kotlin has some special features in the function. So the first thing is you don't have to specify val or var. Why? Because the properties you pass in the function are always immutable. So you can't do this because these are immutable. So Kotlin doesn't want you to change these. Now, the other thing is if you have a function which just immediately returns something. So if there is no code here prior, but it just returns immediately, then you can remove these curly braces and the return and create like an expression body. So what is this? We can do the following. We remove this curly brace here, this return, and we write this on one line. And now we have an expression body, and we could even remove this explicit type here because Kotlin knows, well, it has to be always a string. Personally, I'd like to keep this return type because we will see later if we work with nullable types, then it's really really good if we know if it's an optional type or a non-nullable type. So we have now this. Now let's just return here, and let's see something interesting. If I would say, well, I don't want to return this, I just want to output this like this, and I want to not return anything. As you can see, the result and everything still compiles. And now, if I recompile it, we can see that we get something back from this function, even if we have not provided anything, even if we don't provide a return, because we get unit back. Unit is also like a type in Kotlin, and the cool thing about this is that we can still work with the thing we got back from this. So we can write much more fluent code than if we would have to check, oh, well, this is a void function, we don't get anything back, so we would then have to like handle it differently. Like, for example, also if you're using a mocking framework, you maybe also have already had the problem that, oh, well, this is a void function, I have to like mock these in another way than I would do with a function which returns something. So this problem we don't have because we can use unit. I will go deeper why this is important later when we see the extension functions. So, but let's create a little bit a more complex function. Let's create a create box function which takes an integer for the width and integer for the height. And it just returns a string. And we say then return a box with width, and then we have the width here, and height, and we have the height. So we just call this, we say, well, 150, let's say 100. As you can see, this works fine, a box with 150 and height 100. Now let's say we go back into this code later, and we say, oh, well, we have to add like the coordinates to it. Let's add x and y. And then we see, oh, this no longer compiles, well, I have to add here my x and y. Now, as you can see, because we are in IntelliJ, we see that these properties are now in the wrong order. So now if we see we have a box with 0 and height 0. So let's just say we have this x here, just to show. As you can see now the wrong properties are filled with these values we put in. But maybe you will see this now here in the code, but let's say you create a pull request or a merge request, and in your GitLab or in your other source control, you will then not see what these properties really mean. You will only see 150, 100, 0, and 0, so it's not really that clear what these properties really try to do. And because of that, Kotlin also is, as said, heavily influenced by C#. So what you could do is you can say, well, I want the width to be 150, the height to be 100, x to be 0, and y also to be 0. Now, what we here often do is, because we just passed in 0 and 0 for x and y, if we are not interested in these two coordinates, what we then could do, of course, we could create like an overloaded function and then say, well, I want something where I only want to provide the width and the height and nothing else. But this is quite repetitive, and we would have to do this for each combination. So instead of this, Kotlin knows default arguments. So we can say, well, for x here, I want a 0 by default, and for y, I also want 0. So I can remove this. And what we also could do is, we could also say, well, if we do not provide the height, we could say we just want to take the value we've saved in the width. So what we now could do is, we could just remove everything beside the width. And as we can see, everything still compiles, because this way we've created like these overloaded functions, but having only one function to achieve the same thing, basically. And it's also much more clear what this 150 really means if we use these named arguments here. Now we can even do this. We can say convert to expression body and put this like into one line or into two lines here without the curly braces. So this is how functions work. We will come back to these later, but just to give you a brief introduction. Now the next thing is like, nowadays we are using link or you're using stream to iterate over our lists, of course. But let's keep it a little bit old school and say we start with the for loops here. And let's say we want to iterate over an index. How can we do this in Kotlin? We say we have our I, and we say we want to iterate over a range. So we can say we start with 0 and want until 10. Now we say print line and output what we found here. And as we can see, this outputs 0 to 10. Now often we have the problem that we, for example, have an array and we don't want to output like the array, we want to output only until the array length, but not including the length. So how can we do this? We can use until to do this. And now as you can see, it outputs 0 to 9. Now what is this until function? If we check, this is an infix function, which is called like on the integer, and takes a second integer as an argument. So in C Sharp, you guys already know this for the extension functions, but this is something a little bit special in Kotlin, where you can also use infix, and this means that you don't have to provide like the parentheses, but we will see this later in the extension function. But just to give you a brief introduction about this. Now, this until here, this returns an int range, so what we can now do is we can say, well, I want to step of 2, so I want to jump over each second element, so we get only 0, 2, 4, 6, and 8 outputted. And let's say we want to go from, let's say, 10 to 0. How could we do this? Well, we can't use this, because 10 is always greater than 0, and we can't iterate over this. It will never even iterate once. But instead, we can use down to 0. And as you can see now, this outputs 10 to 0. Now, we can, of course, also use the step here again. As we can see, 10 to 0, which jumps over each second element. Now, this is how we can do iterate over the indexes. But let's say we have a list here instead, and we have list of, and we have an hello and NDC here. Now, just a quick side note, lists and sets and also maps are all immutable by default in Kotlin. So if I would say here list.add, this will not compile because there is no add on this list interface. But I have to change this to mutable list of to be able to add an element to a list or remove an element to a list, because Kotlin wants us, as already mentioned, to use immutable code whenever possible. So, but let's change this back to list of, because we don't need to add something. Now we can iterate over this by using this list we have here. As we can see now, we get hello and NDC back. Now, Kotlin has many different functions on the list. As you can see, you can almost everything you can think of, and you have already, if you wanted something, you then gone to Stack Overflow, copied this, and put this into your code. If you want some like special kind of filter, most of it, when not everything I ever needed, is already here from Kotlin implemented. So associate by, also you have your different filters, filter not null, so remove the null elements, and all the things are already here, and you could use them. So, but we keep it simple. We say we want to use this with index. Now, what does this with index do? This like creates an index beside our value, so that we can like access the current index we are looping through. And what we now could do is, of course, we could say we have this i.value or i.index, but instead of this, we can use destructuring. So what can we do? We can say, we can use parentheses, and we can say the first value of this, like it's like a tuple here. We can use the first value and save it in I, and the second and save it in value. And now we can access it like this. And as you can see now, this outputs the index beside the value without having to like access the property of this object of which of this indexed value. So the next thing is, what do we often do in for loops? We have already, as you have seen, we have to check for null. So to fix this, Kotlin has implemented, in my opinion, a really cool way to do null safety. So let's say we have our function here, we have our hello again, and we have our string here, and we return a string. Now, how would you check for null if you want to check if the property you put in is null or not? Well, you would say normally we have a name not equals to null, then we return hello name, otherwise we say return null. Now we get two errors here, one error and one warning. As you can see here, Kotlin tells us, well, name not equals null is always true, because Kotlin tells you, well, this string here doesn't allow to put in a string type or an object which is null. So basically we can check this. If I say I have this hello here and I pass in null, this will also not compile, because Kotlin knows two different types for each of the types you have. It knows the non-nullable type and the nullable type. The nullable type is if you add a question mark behind. As you can see now, this value, check is now gone away, and Kotlin knows, okay, it's nice that you use this not equal null to check for null, but this return here doesn't work because we said this has always to be a string. So to fix this, we add a question mark here. Now, what does this question mark really do? If you see the compiled JVM bytecode, there is not just like another type created, like called nullable string or something like this. It's just, it creates comments in your JVM bytecode, and because the JDK compiler doesn't read these comments, but the Kotlin compiler reads these comments and find out, oh, okay, this function here takes an optional string and returns an optional string. So your bytecode is not manipulated or anything like this, but it's just comments in your JVM, in your bytecode. So this is now fine, but let's make a little bit of more of a complex example. So I have to create two classes here. I will talk about classes later. I just have to create them here to show you how a more complex example can work. So let's say we have a first name here, which is a string, and we have an address here. And this address has a street. Let's keep it simple. And now let's say we have a function here and call this getStreet. And it takes a person and it returns a string. Now, we could say, for example, well, if the person not equals null, and the person.address not equals null, in this case, return person.address.street. Now, as Kotlin already tells, well, there is nothing nullable here. So let's say, well, we want to allow a nullable person to be put in, and we also want to allow a nullable string to be returned. So otherwise, we say here return null. As you can see now, everything compiles. Now, but let's change this address to also be nullable. Now, as you can see, we can see in IntelliJ we have checked for this address to be not null and for the person to be not null. But Kotlin tells you, well, you're making things way too difficult. You can make this much easier. So we can use save calls instead. You guys from C# already know this. So we can use person and then use a question mark to say, well, if this is not null, then call address. If this is not null, then call street. Now we can remove everything here and even put this in one line. And now we have created the exact same code as before, but with these safeguards, we could make it much more concise. And if we now say we have our street here, and we say we have getStreet, we pass in, let's say, null, then of course we would get null street back. So this string here is implicitly nullable. So let's say we want something else. We want this string. We really want a string. Then, as you can see, we get an error because you can't assign a possible nullable value to a string, to a not nullable string. So to fix this, we can use the else operator and can say, well, if this getStreet is null on the left side, we use the right side of this check and can say, for example, no street. And the street here, as you can see now, contains no street. So this is how you can use the null safety to make your code much more concise and also make sure that everything you pass in or return to a function really is it has the type you expect it to be. So now after the null safety, let's go a little bit more into functional programming. So let's have our list here again, and we have our list of, and we say hello and world and NDC. Now, what we'd like to do is we want to do a filter on the list and like filter all the strings which are not of length 5. So how can we do this? Well, let's create just a function, call this string length 5, and we pass it in the string, and we say string length equals 5. And now we can have our result here, and we say list.filter. Now, as you can see, there are many ways to do this, but let's start simple. We have a filter function which just takes a lambda, and what we then can do is we pass it in this element, and we say is string length 5 and pass it in the element here. Now, in Kotlin, if you have a function which if you have a function which, a lambda which takes only one element, one input element, you can remove this and say this is implicitly it, because it knows that it's the only thing that goes into the lambda, so it has to be this it. Now you have to be careful, of course, if you have like something, a wrapped lambda or something like this, then if you're not sure that you explicitly know what this it really is, just explicitly state it, because otherwise it gets complicated to read the code sometimes. But in here, I think it's easily readable. Then the other thing you can do is, if you have a function and the only parameter of this function is a lambda, like here, you can move the lambda out of the function, and if then the function has no more arguments in it, we can just remove them at all, and now we have just our lambda here with our isStringLength5 call, and this is a little bit more concise. So, but we can go further. We can make this isStringLength5 itself a lambda. So let's just copy this, comment this out, and say we have this is now a variable instead, and we can then say this is a lambda here. We can create a lambda from it, and as you can see, nothing really changed. It's lambda is still like a normal function. But what you could do also is you could say, well, this takes a string and returns a Boolean. And then you could, of course, remove this here and use it, because Kotlin now knows what the interface of the class of lambda really is. So, but because now this is a lambda, what we could do here is we could say that we just pass this lambda to our filter. And now, as you can see, this is exactly the same. If we check the result here, we can see that this still outputs hello world. So this works fine. And so this is really cool, but wouldn't it be cool if we just could call this isStringLength5 on our string itself? So if we could say hello, for example, and then isStringLength5. The guys of you who work with C#, of course, have these extension functions. So, but for the other ones, what are extension functions? Well, let's just remove this and remove these two things here, because we don't need them. So let's say you want to call a function on a type which already exists. How can we do this? We can create a so-called extension function you have already seen before with these until we have seen at the loops, or the step function. So what we now could do is we can say we want to call this isStringLength5 on our string. And now we can remove here this properties argument and can say, instead of the string we pass, we use this, because this refers to this string we are using it on. Now, it's important to say, many of the people who see extension function for the first time think there is some kind of black magic behind it, that like the class gets, like the bytecode gets changed or something gets added to an existing class. This is not the case. What really happens behind the scene is it creates a function in the basic library, which takes as a first argument, like you would do in C#, this string here, and all other arguments you pass in here as the rest of the arguments. So this way, it's really easy to extend functionality to existing classes, even if you don't have access to them. For example, if you're using a library, you can just extend them by using an extension function instead of inheriting from it. So as you can see now, this now compiles and we get true. If I remove something, then I get false back from it. Now, as you can see here, the cool thing here is, okay, I can do this on a string, but wouldn't it be nice if I could call this also on a nullable type? So let's say we have a var here, and this is a nullable type, and I initialize it with null. Now, if I could call this on a nullable name, well, I can do this. I just need to say, well, this is not only on the string, but also on the nullable string. Now I have just to check if this here exists. And now I can call the isStringLength5 function on a null type, because as already mentioned, we just call this isStringLength5 function with this name as an argument. So we can now do this. What we could also do is we could create extension properties. So we have this name here, and we say we want to create the property like this. We can then say this is not a function anymore, but this is a property. We can then say this is of type Boolean, and can say we have a get here, and can then say, and can then say, by using get, we get back if this is length 5. So as we can see here, this returns false, of course. If I add here hello, then this returns true. So this way you can use extension functions to extend your existing classes or even like strings or your primitive types by really easy without having to like inherit from it. Yeah.
Does this mean that a null is implicitly cast to boolean false or something?
Yeah, it's because here it's because of this save call, because this returns then false because it isn't length equals to 5. Yeah, exactly. Yeah, exactly. Now, what we could also do is, and let's now talk a little bit about how classes work. So we have a class here again. We have this person here, and let's make this really simple. We have this string. Now let's say we have a person1 here, and let's initiate it with first name. Now, how do classes work? Now, as we can see, we have here this val. What this means is we don't need like a body of the class, because if you don't pass in anything explicitly, if we use val, it will create a standard getter for us and will create hidden private setters. So if we say we have this person1 and say first name, as we can see, we can access this with my name, but if I try to set this to something, as you can see, this does not work, because we don't have specified that this is a var, but if I change this to var, as you can see, we can reassign it. So under the hood, you are not really accessing the property, but you are accessing the getters and setters which are created from Kotlin implicitly. Now, let's say you want to inherit this person. Let's say we have this class here, let's call this teacher, and we want to extend from this. And I don't care right now. Now, as you can see, this doesn't work because this type is final. Well, because by default, all classes in Kotlin are final and cannot be inherited from, because Kotlin doesn't want you to really use inheritance. They want you to use composition or like the extension functions or extension properties whenever possible. But of course, you can do this. You could say you have this. You can make this class open, so you can extend to it. But as already mentioned, if you just want to add like an additional function to it, where you, for example, have to access the first name, you can just create an extension function. So you could do the following. You could say you have your function person here, and then you can, for example, say shouted name, and you can then say this is first name dot this dot first name dot uppercase. And now, if I have my person here, I can just call person1.shouted_name, and I have access to it. So I don't have to use inheritance if I want to add functionality to it. Now, what's also, let's say we want to create like a body for a class. If you'd like to use like static functions, you could use a companion object and could then say, well, I have my I'm static here, and you could then call person.I'm static, like with static functions. You don't need static functions because Kotlin, as already mentioned, supports top-level functions. You can just create like a top-level function and then pass something in it if you need something special. But of course, if you have like your person class and you have some state in there, even if it's not an object, then you can use this to have your static types, have your static functions and static properties. Now, if you want to create like a private or your own additional variables which are not in the constructor, you can use it like this. You can say, let's say, remove the shouted name here, and we say we have our shouted name, which is a string, and we take this from the first name, and we say get here, and we say, let's just call print line here, and we say get called. And now we can use field. Field is like this implicit field which lies behind this shouted name. And we then return this field. And we have the set value, where we can say print line set called. And we have the field, which is then new, the value we pass in, and we say field equals value. Now, if I now access this here, if I access here shouted name, then as we can see, this returns my name in uppercase. If I now set this to something else, we can see that set was called from Christian to empty. So as we can see, this works, but this is like how get and set works under the hood without you providing something. It just returns the field or sets the field. All right. Now, what also is interesting with classes in Kotlin is, let's say we have these two properties here. We have person1 and person2. Now, if I compare these two, by the way, double equals in Kotlin means that you compare by value, so it uses the equals, and with triple equals, it compares the references. So as you can see, this returns false, but clearly, these are the same objects if you are just looking at the values. So we can fix this by using data class. As you can see now, this returns true because data classes provide for you the equals, hash code, and toString methods, which then have the possibility to let Kotlin really check the input or the data of your class. So what you also could do, let's say we add a last name here, which is a string, and we can then say, let's do it like this and like this. And now what you also could do is destructuring of data classes. So what you could do is you can say, well, I have my first and my last, and I used person1. And now if we check what is written in first and in last, as you can see, this outputs my first and my last name, because the data classes support this kind of destructuring. So this is how you can use the data classes. Now, before we go to another topic, I'd like to also give you an introduction to these infix functions I've shown you prior with this until, how you can create one yourself and can create like your own DSL, your own custom DSL. So for example, for the ones who have already used Gradle with the Kotlin DSL to create your configuration, they are also using these infix functions. So let's say you have a person here, and let's create just a function here and say you have a person. We could, of course, just now create this in our person, but I want to show you how can you do it with an infix and an extension function. So you have your person, and you say, well, I want to have a greets function, and I have a second person here, and I want to have like this dot first name greets person dot first name. So we can now, of course, do the following. We can say person1 dot greets person2, and then we get back Christian greets Christian. Yeah, it's not. It's I'm greeting myself. So let's change this to max so that I'm not greeting myself. So now, as you can see, this works. But now we can do something cool. We can say, well, we use an infix function. And now nothing really changed, but what we could do now is we can remove the parentheses here. And we can remove this. And this still compiles. And now this way you can create like fluent code. And you could then also do, you could of course then also like put other function calls to it, like we have seen prior with this int range. We could do 1 until 10, and then step 2, and then so on, so far and so on. And because of this, this is really cool to write your own like custom DSL functions or your custom DSLs, or like write fluent code. So one more thing which I think is especially interesting for the ones of you who work with Java or with languages which are not C# is like, let's say you have your big decimal here. You have like 1 here, and then you have like your other big decimal here, your 2. So often what you have to do is you would have to use the function, the .add function, to have the result here to say bd.bd add and then bd2 to put them together. And that's also why some companies said, well, we are using double, it's good enough because we don't want to handle this. So Kotlin fixed this, and we could now do the following. We can say we use plus here, because Kotlin provides these operator functions. What do they do? Well, you can like override this plus, minus, multiplication, and division by yourself. Well, of course, this can be dangerous if you handle it wrong, because you could just say, well, if you use minus, then it can be plus, and vice versa. But of course, you have just to be careful by yourself. But the cool thing here is that you could also, let's say, if you have like complex objects and you would like to put them together, you could override this plus and then do the things under the hood you really like to happen if you use this plus. So this is also cool. Like this is also, like, as you can see, this is an infix. This is an inline operator function. Inline means that during runtime, the code which is the function which is written here will get inlined in the code where it's called. So before we go to the last part, I'd like to show you a little bit about the interoperability. So we have this Java class here. I've just created a normal Java class in my code, and what I now can do is I can say I have my Java here, and I can access the Java class from my Kotlin code, and can then have here my hi from Java is just a function which I've defined in my Java class. As you can see here, this is now this is nullable. Why is this nullable? Because I've added an add nullable annotation to my Java class, to this function in my Java class, to tell Kotlin, well, this the return of this hi from Java may be null. So I, of course, could now call it like this, but I can also, of course, extend my Java class. I can say hi from Kotlin, and can say hi from Kotlin, and can then here access hi from Kotlin. So I can even, of course, extend functionality from Java libraries or from many other things. That's, for example, also how Spring does many of its features. By, for example, you can go into the data in your, if you have something to change about an interface, you can just add new functionality to the existing Spring things. So this is how you can use interoperability. And as a last topic, I'd like to show you about lazy evaluation. So let's say we have a function here, and this is a really expensive. This is really expensive to do. So we have here our, let's say we have a Boolean here, and we say here, really expensive call. And we return just true. Now let's say we have an if here, and we say, well, if the first thing passes, then we want to do this really expensive call, but in here we also need the value of this really expensive call. What could we do? Well, we could just call here this really expensive call again. But the problem, of course, is we do this really expensive call twice. So what we could also do is we could say we have our check, which is really expensive here. We will do each time without, even if it's not, if we are not in this true case. But the problem here, of course, is even if we don't go into this case here, we will still get this call here because we have already evaluated the value for this really expensive call. So to fix this, Kotlin knows delegation. You can use delegation in extremely complex ways, but Kotlin itself offers some easy way in. We can say, well, this is a string, this is a Boolean, sorry, a Boolean, and we can say by lazy, and can then pass our function call into this lambda from this lazy here. And as you can see, this lazy, this is just like a lazy initializer. And I won't go into this, what this really does, but as we can see now, something interesting happened. There was no call to this really expensive function we have here. But if I change this here and say check, and I say here, I assign check to it, as we can see, we get only a call once, because And it happens only at the first time you call it, and then it gets cached and just reused. So this way you can use lazy evaluation with delegation to only call your code once and then reuse the value only if needed. All right. So it's done. Thank you for attending. My name is Christian Woerz. If you'd like to see the code I've shown you, just go to my website. If you'd like to get into contact, please just send me a link, send me something on LinkedIn. I will gladly accept it. And yeah, thank you for attending.